Okay, so we have 2.2 today. Today we are getting what's called a conditional statement. And then all we're doing in this is we're identifying the hypothesis and the conclusion. Okay, science, hypothesis, what does that mean?
Guess.
Your guess. Conclusion, what does that mean? Your answer. Good. Okay, so first thing we have to do is we have to define a couple terms. First of all, a conditional statement. What is a conditional statement? A conditional statement is a math statement in the if-then form. So we're going to get a statement that says if this, then this. That's called a conditional statement. Okay, we also have a hypothesis. Now, in science, hypothesis means your guess. So in these types of statements, the hypothesis is going to be the if part. So the part that says if this, that's our hypothesis.
Good.
So then the conclusion is the then part. Okay? So the hypothesis is the if part, the conclusion is the then part. So we have to remind ourselves, though, that even though we are given a conditional statement, that doesn't always mean it's true. So sometimes a conditional statement might be true, sometimes it might be false. And we might be asked to identify if it is true or false. So we have to know how to do that. So example 1, all you guys are going to be doing in these examples is we are going to identify the hypothesis and the conclusion of each statement. Okay, that's all we're going to be doing. So what I'm going to do, I'm going to underline the hypothesis and I'm going to put a box around the conclusion. Okay, that's just me. Alright? For these examples, well, because what's really going to happen is you are going to be asked on a test, identify the hypothesis, and you'll just have to circle it. So all we're going to do is we're going to underline the hypothesis and we're going to put a box around the conclusion. That's all we're doing. So here's the first statement. I'm not asking you if it's true or false. I'm just asking what is the hypothesis and what is the conclusion. So if 5x plus 40 equals 10, then x equals negative 6. The hypothesis is the if part, so what's the hypothesis? 5x plus 40 equals 10. That's the hypothesis. The conclusion is the then part, so what's the conclusion? X equals negative 6. That's all we're doing, and I'm not asking if it's true or false. All I want to know is what's the hypothesis and what's the conclusion. Example 2. This time we are actually asking if the statement is true or false. So write it down. Okay, so how do I determine if it's true or false? I'm actually going to solve the hypothesis part. So I have 2x minus 3 equals x plus 5. And this is just solving equations with variables on both sides. So what do I want to do first? Well, my goal is to get all variables on one side, all numbers on the other, right? So which variable do I want to move? Do I want to move the 2x or the 1x? The 1x. So I'm going to subtract 1x from both sides. Because x minus x cancels each other out at 0. 2x minus 1x is 1x minus 3 equals positive 5. And then last step, what do? I add 3 to both sides. Negative 3 plus 3 is 0, so I'm left with x equals 5 plus 3 is 8. Was that my conclusion? Yes, so is my conclusion true or false?
True.
It's true. So what do I do to answer? True. That was the question. Is it true or false?
Oh my gosh, this is easy.
Okay, guys, good question. Could I have just taken x equals 8 and plugged it back in? Yeah, I could have. So what would I have gotten then? Same thing, but I would have had 2 times 8 minus 3 equals 8 plus 5. 2 times 8 is 16, minus 3 equals 8 plus 5. 16 minus 3, that is 13, equals 8 plus 5 is 13. Is that a true statement? Yes, so our conclusion is true. So we could have done it either way. Either way is right. Okay, guys, example 3. Okay, example 3. What is my hypothesis here? If 4 times x plus 6 equals 22, then 4x plus 6 equals 22. Okay, so my hypothesis is that 4 times x plus 6 equals 22. And my conclusion is that 4x plus 6 equals 22. I want you to determine if it's true or false.
It's true.
How do we do that?
No.
We're going to start solving. That's why I had you solve all the way through in example 2.
False.
How do I solve this thing?
Distributive property.
Excellent, distributive property. So I'm going to distribute 4 into the parentheses. So what would I get? 4 times x gives me 4x, and 4 times 6 is plus 24 equals 22. Is that what our conclusion said?
No.
Nope. So the conclusion is false. What did they forget to do?
They forgot to distribute.
They forgot to distribute 4 to the 6. So you will maybe will also get questions where they ask you what was wrong or what's the incorrect step. Okay. All right, example 4. Guess what? This is the last one. Oh my gosh.
You're a liar. I think you're lying. How many examples are there?
Okay, guys. All right. So here's my hypothesis. My hypothesis is if 10 minus 3 times 2x plus 2 equals 9, then 10 plus 2x plus 2 equals 12. My conclusion is 10 plus 2x plus 2 equals 12. My hypothesis, if 10 minus 3 times 2x plus 2 equals 9. So what am I going to do first? I'm just going to start solving this like I normally would. Okay? So what's my first step in solving this one?
Distributive property.
Distributive property. Am I distributing a positive 3 or a negative 3?
Negative.
That negative 3. So let's distribute the negative 3. So what would we get? 10. Negative 3 times 2x. What's that? Negative 6x. Negative 3 times positive 2. Negative 6 equals 9. Is that what they have as the conclusion?
No.
No, they're way off, right?
Yep.
So is the conclusion true or false?
False.
False. What did they do wrong?
Everything.
Okay, so what did they do wrong here? They added 3 to both sides when they should have multiplied. So that was the incorrect step. So there are going to be questions on the homework, on the test, where you are asked, what did they do wrong? Okay? How's everybody feel about this? Thumbs up, thumbs down. Not too bad, right? Okay, so your homework for 2.2 Is worksheet 2 all of them? I think it's 14 problems. Okay, so 2.2 all.